Hello everyone and welcome to the lecture on Amazon EMR, previously known as Elastic Map Reduce, but now we just call it as EMR. So this lecture will contain all these topics. What is Amazon EMR? Understanding clusters and nodes, submitting work to a cluster, running steps to process data in Amazon EMR, Amazon EMR cluster lifecycle, Amazon EMR cluster failure handling, AWS integrations, and architecture of Amazon EMR. So what is Amazon EMR? Amazon EMR, formerly Amazon Elastic Map Reduce, is a managed cluster platform that simplifies the running of big data frameworks on AWS infrastructure. EMR specifically supports popular big data frameworks such as Apache Hadoop, Apache Spark, making it easier for users to leverage these powerful tools. The primary purpose of Amazon EMR is to enable the processing and analysis of large-scale datasets efficiently. Users can utilize EMR and its supported frameworks for various data analytics purposes and to power business intelligence applications. Amazon EMR provides capabilities to transform data and facilitate the movement of large data volumes between different systems. EMR seamlessly integrates with other AWS services, which allows users to move data into and out of popular AWS data stores like Amazon S3 and databases like Amazon DynamoDB. So let's understand the concept of clusters and nodes. Cluster, which is a collection of EC2 instances. A cluster in Amazon EMR is a group of Amazon EC2 cloud instances working together. This forms the central component of EMR, which allows for distributed processing of big data. Next is node, which is an individual instance in a cluster. Each EC2 instance within an EMR cluster is referred to as a node. Nodes are the building blocks of the cluster, each playing a specific role in the distributed application. Node types, which perform different roles in the cluster. Amazon EMR assigns different roles to nodes within a cluster known as node types. Each node type has specific software components installed, enabling it to perform its designated role in the distributed application such as Apache Hadoop. First one is primary node, which manages the cluster. The primary node is responsible for managing the entire cluster. It runs software that coordinates data and task distribution among other nodes. It tracks task status and monitors cluster health. Every EMR cluster has one primary node, and it is possible to have a single node cluster consisting of only the primary node. This is something which use for development work. So we have one node and that has all the node types like that is primary node as well as core node, which I'll talk about now. Core node, which runs tasks and stores data. Core nodes perform two crucial functions: running tasks and storing data. They execute the software components that process tasks and store data in the Hadoop distributed file system HDFS. In a multi-node cluster, there is at least one core node. So there will be one primary node, one core node. This is for a multi-node cluster. But for a development workflow, you can just have one single node which will act as both primary as well as core node. Next, task node, which runs tasks only, and this is an optional node. Task nodes are optional components in an EMR cluster. They are designed to run tasks but do not store data in HDFS. Task nodes provide additional compute capacity to the cluster without increasing storage. So let's see how to submit work to a cluster. So first you can define work as steps during cluster creation. So this method involves providing the entire definition of the work to be done in functions that you specify as steps when you create a cluster. It is typically used for clusters that process a set amount of data and then terminate when processing is complete. This approach is best for one-time or batch processing tasks where the workload is well defined in advance. Submit steps to long-running clusters. With this option, you create a long-running cluster and use various tools to submit steps as needed. These tools include Amazon EMR Console, the Amazon EMR API, or AWS CLI. Each step may contain one or more jobs This method is flexible and allows you to add work to the cluster over time, making it suitable for ongoing or variable workloads. Thirdly, connect via SSH and use application interfaces. This approach involves creating a cluster, then connecting to the primary node and other nodes as required using SSH. Once connected, you can use the interfaces provided by the installed applications to perform tasks and submit queries. This can be done either through scripts or interactively. This method offers the most direct control and is ideal for complex, interactive work or debugging. Running steps to process data in Amazon EMR. So first one is submitting or ordered steps to an Amazon EMR for data processing. So you start with step definition, which is a unit of work containing instructions to manipulate data, and then processing software, which is installed on the cluster to execute the instructions. So example process may look like this. For example, a 4-step data processing typical workflow. So first you submit an input data set for processing. Second, you process the output of the first step using, let's say, a pig program. Thirdly, you process a second input data set using Hive program. So you will build a chain. So you have first start with data set, you have first step, which is a pig program, then Hive program, and lastly step 4, you write an output data set. Okay, data flow in Amazon EMR. So general process of data movement and storage. So you start an input data storage. So files are stored in chosen underlying file system. So it could be Amazon S3 or HDFS. Then data processing. Data passes from one step to the next in the processing sequence. And finally, output data storage. Final step writes output data to a specified location, for example, Amazon S3 bucket. And then step execution sequence. Order and state changes of steps during processing. So start with initiation. A request is submitted to begin processing step. Then comes the initial state. The state of all steps is set to pending. First step execution. So first step state change. First step changes to running. So if there are a couple of series of steps, so first will become pending from pending to running, and other steps remaining pending state. And after step completion, state change. So the step will change to completed, and next step will start, and the state will change for the step number 2 to the running. And this process repetition and pattern repeats for each step until all is completed. And end of the processing, all steps complete and processing end. So this is a successful happy scenario. And let's say in case of a step failure handling, so options for managing failed steps. So failure step. So failed step changes to something called as failed state, and the default behavior is remaining steps are set to cancelled and do not run. Some other alternative options: ignore failure, allow remaining steps to proceed, or immediate termination, terminate the cluster immediately. Okay, now let's see Amazon EMR cluster lifecycle. So cluster lifecycle, this is about the cluster lifecycle. What we have seen is previously is about the steps, or when we submit jobs. So a job will have multiple steps and what states it will go through. Now we are looking at the cluster's lifecycle, and this is separate from the job what you submit to the cluster. So first one, starting. This one, provision EC2 instances. Amazon EMR begins by provisioning EC2 instances in the cluster according to your specifications. During this phase, Amazon EMR uses either the default AMI for Amazon EMR or a custom Amazon Linux AMI that you have specified. The cluster state is set to starting during the initial phase. Next state of the lifecycle is bootstrapping. Run bootstrap actions. In this phase, Amazon EMR executes the bootstrap actions you have specified on each instance. These actions allow you to install custom applications and perform any necessary customization. The cluster state changes to bootstrapping during this phase. Next, you install native applications. So Amazon EMR installs the native applications that you specified when you create the cluster. This may include applications such as Hive, Hadoop, Spark and others. And this step ensures that your cluster has all the necessary software to perform its intended tasks. then it goes to running state. Each execute cluster steps. So after bootstrap actions are completed and native applications are installed, the cluster state changes to running. At this point, you can connect to the cluster instances, and the cluster begins to sequentially run any steps you have specified during cluster creation. You also have the option to submit additional steps which will run after any previous steps are completed. Next is waiting. So cluster awaits next action. So once all steps have run successfully, the cluster enters a waiting state. In this state, the cluster is idle and ready for further instructions or termination, depending on its configuration. And next state phase is terminating. So cluster shuts down. The cluster enters the terminating states in two scenarios. First one, if the cluster is configured to auto terminate after the last step is complete. Or second one, if you manually initiate the shutdown process for a cluster that was configured to wait. During this phase, Amazon EMR begins the process of shutting down the cluster and its resources. And finally, the last phase is terminated. Cluster process complete. This is the final state of the cluster life cycle. Once the termination process is complete, the cluster enters the terminated state, indicating that all cluster resources have been released and the cluster is no longer active. So just to summarize, this is how the whole flow. So we have launch cluster, then starting, next one bootstrapping. If bootstrapping successful, so let's go left hand side. So bootstrapping successful, no. So shut down the cluster, terminating state, and finally you will see terminated with errors and processing failed. So this is if the bootstrapping successful, when you install the native application or bootstrap something to the cluster. Next, if everything goes fine, then process steps, then it will go to running state, and if processing successful, let's say no, then again shut down to the cluster, and again same error. But if processing is successful, then it will check if cluster is set to auto terminate, and if yes, it will shut down the cluster, go to terminating state, and finally terminated, but processing is completed successfully. Next is let's say cluster is not set to auto terminate, so no. So cluster is still waiting or idle, so it will wait for instructions. So user wants to do some more job. If user adds some more steps, it will again go to running and it will follow this sequence. But in between, if user decides to terminate the cluster manually, then again it will go to shutdown cluster terminating state and terminated. Okay, Amazon EMR cluster failure handling. So a failure during the cluster life cycle causes Amazon EMR to terminate the cluster and all of its instances unless you enable termination protection. If a cluster terminates because of a failure, any data stored on the cluster is deleted and the cluster state is set to terminated with errors. If you enabled termination protection, you can retrieve data from your cluster and then remove termination protection and terminate the cluster. Okay, these are the integrations which are available with Amazon EMR. So we have Amazon EC2 for the instances that comprise the nodes in the cluster. So it's made of EC2. So that is the first integration. Then Amazon VPC. To configure the virtual network in which you want to launch your instances. Amazon S3 to store input and output data. Amazon CloudWatch to monitor cluster performance and configure alarms. AWS Identity and Access Management IAM to configure permissions. AWS CloudTrail to audit requests made to the services. AWS Data Pipeline to schedule and start your clusters. AWS Lake Formation to discover, catalog and secure data in an Amazon S3 data lake. So let's see the architecture of EMR. So first one, we have storage layer, which consists of HDFS, EMRFS or local file system. So HDFS, which is a distributed scalable file system for fault tolerance and immediate result. So HDFS stands for Hadoop Distributed File System. Then EMRFS, which extends Hadoop for direct Amazon S3 access, ideal for input-output data. And then local file system, it uses EC2 instance store volumes for temporary lifecycle bound storage. Next, for the resource management, we have Yarn and EMR agent. So Yarn, yet another resource negotiator, is a centrally manages cluster resources for multiple data processing frameworks. EMR agent on each node administers Yarn, maintains cluster health, and communicates with EMR. And this is optimized for spot instances. So application masters run only on core nodes for job continuity. Next is about the processing frameworks. So we have two, MapReduce and Spark. MapReduce, which is an open source model for distributed computing, simplifies parallel processing. And second one, Spark, which is a cluster framework using directed acyclic graphs and in-memory caching for faster big data processing. Both frameworks support various high-level interfaces and languages. Next, about this layer, applications and programs layer, and this consists of Hive, Pig, and Spark ecosystem. Hive, which is a data warehouse software for SQL-like queries and data summarization. Pig, which is a high-level platform for creating MapReduce programs using Pig Latin language. Spark ecosystem includes Spark SQL, Spark Streaming, Spark MLlib for machine learning, and Spark GraphX for graph processing. Supports multiple libraries and languages for flexible data interaction. Then integration, which we have seen, S3, EC2, and Spot instances. So seamless integration with Amazon S3 for cost-effective and durable storage. You can leverage EC2 instances for scalable compute resources. And EMR is optimized for Spot instances to reduce cost while maintaining processing reliability. And that's all. Thanks for watching.